Caleb, tell me about yourself. Thanks for coming on. I know you're a busy guy working late shifts and all kinds of stuff, but tell me about yourself. What do you do at Boxbow?
So I'm actually the director of our managed services group, and we help long-term support customers. So do big Kubernetes implementations for them. A lot of times that involves Rancher. Sometimes it involves edge deployments, and we're here 24/7 to make sure that any issues that they encounter, we'll take care of for them.
Oh, awesome, awesome. So, I mean, real quick, I know a lot of my audience probably has no idea what Boxboat is, and really what you guys do is kind of a weird thing. Like, I didn't know there were companies that specifically help people do what you guys do. So, real quick, I guess in a elevator pitch nutshell situation, what is Boxboat, and what do you guys do?
So we're a DevOps consulting company, and our whole goal is to make your DevOps processes faster. So if you're today deploying to virtual machines, it takes you a couple weeks to get a new deployment out there. We want to come in, help you set up CI/CD, help you set up Kubernetes, and get you on a program that you can push change to your code, have it automatically built, tested, and deployed all within 20 minutes, all the way through your pipeline, all the way to your cluster. So taking from weeks or days down to minutes, that's what we're all about.
Wow. So I imagine when you encounter these companies, I'm curious. I wonder if these companies try to do it themselves and they realize, yeah, we can't do this. We need some help. Or are they just coming to you just from the get-go? Or is it kind of a mix of both?
It's probably a mix of both. So there's a lot of boilerplate that people very quickly learn that I'm going to have to keep implementing. Somebody's probably already solved this. So the first thing we do is we go to GitHub and we check out, hey, what's out there? What are people using for this? And then I think that's when, people start to get overwhelmed because there's so many different projects that focus on niche things, right? Say you're building for a specific language, you may have your Java or your Spring, based build tools, and then a new developer introduces Node.js, so all of a sudden you're trying to figure out how to get JavaScript building. So I think that there's a lot of common things that you're going to use across your stack, and then there's a lot of very niche things. So once you start trying to pull those in and kludge them together, that's when it can really get time consuming, and really having an expert who's done this with most of these sets of tools and combine them in every way possible is going to save people a lot of time, and just get them up and running a lot quicker.
I love that because I know in my experience in IT, half the battle is just figuring out what you don't want to do. Because you have to explore everything. Like, will that work? Will that work? Will that work? I don't know. And then you do it, and it doesn't work. So you end up just whittling down to the exact right solution. But you guys have already done that a million times over. And can help people find that path very quickly.
Definitely.
So the main topic of this interview is to talk about Rancher. What the junk is Rancher?
So Rancher is great. It's we have. Let's start with what is Kubernetes, right? So Kubernetes is basically a platform as a service, right? Think of it as the big app server in the sky. You can define your applications in these standard ways that Kubernetes has laid out for us, and then you can run them on a Kubernetes cluster locally. You can run them on a Kubernetes cluster in the cloud across many different cloud providers, and there's a bunch of different. The biggest problem, though, is there's a bunch of different flavors of Kubernetes, right? There's different versions, different flavors, different ways to access them.
And real quick, just to kind of like zoom out a bit, comparing Kubernetes to like Docker and just basic containers, how would you compare those two, and what's the main difference?
Yeah, so Docker is really part of the building block that builds up Kubernetes. So Docker is going to be like a single instance on a single computer. I want to run multiple containers on this computer. I'm going to run that through Docker. Kubernetes basically expands that out to, I want to run these containers just in a platform, just on many different computers, spread across the cloud, or spread across different regions. So you can basically set up Kubernetes and it'll be like a bunch of Dockers repeated,
Oh, dang.
and
Okay.
it'll orchestrate and schedule containers to run, and basically give you that scalability. You don't have to worry about what happens when one of my nodes fails, right? Kubernetes will take care of that for you.
So like one fails and just rebuilds it, destroys it, rebuilds it. No big deal.
Yeah, or it'll just take it out of the rotation. Yeah, so there's many different flavors of Kubernetes. So every cloud provider has their own flavor of Kubernetes that's slightly tailored to work with their cloud. Or you may have a on-prem distribution that's slightly tailored to work with VMware or bare metal. So
that's what's confusing for me, and I know a lot of people is like we hear, okay, learn Kubernetes, and like, okay, cool, how, where? Because you can do it a million different ways.
Exactly.
There's Minikube and all these and there's Kubernetes like K3S, and there's like Q4S or something like that, like something smaller.
K3S, yeah.
K3S, like what is all? It's so confusing.
Right.
And I know like Azure and AWS and GCP, like they all do it in a different way. It's still the same technology, but like to be able to, and I know a lot of people now are multi-cloud, right? It's not just AWS, learn those tools.
Exactly.
It's, how do I spread all this out and manage it in a good way? I'm confused. Like, what do I do with that?
So Rancher is a great tool to help with that. And what Rancher does is it allows you to connect all of these different clusters and provide a single pane of glass to interface with them. So it'll centralize your access controls, and it'll centralize your access point into all of your different clusters. So, and it gives you a great UI on top of that so that you can actually see what's going on with your cluster. I know, a lot of us love the command line, but, if you're just getting into it or you're trying to view many different clusters at once, what's going on with all of them at one time, it's got a nice UI for that as well.
See, I like that because, yeah, I do love the command line. Anytime I can know it well and get into it, it's fun. But when you're managing something serious, like something in production, it becomes kind of overwhelming. Like, do I have to log into all these different things? How do I parse the information? What commands do I need to use to get what I want? To have a UI that kind of pulls all that together is comforting in a lot of situations.
Definitely. And when you're responding to an issue at 3 a.m, having a blinking red text on a panel that's telling you exactly where the issue is
yes. Oh my gosh.
Then you can go get on that specific cluster with your command line and fix it. But just having something that throws the flag up to tell you, okay, you need to look here, is a godsend for sure.
Oh yeah. So essentially, Rancher is something that will help us manage Kubernetes pretty much wherever it's at.
Exactly.
So I can deploy it to AWS, Google Cloud, have it on-prem, anywhere, and it's just there.
Right. And it's even in its latest release, they've introduced a new way to manage up to thousands of clusters, and that's called Fleet.
I love all the names that come out with Fleet.
Right.
Wasn't that a new Twitter thing they did? It was yeah, I think it was, where they had the short versions of stories.
Yeah, I think it rings a bell.
Anyway, so at the Fleet, so you can manage just a butt ton of Kubernetes clusters.
Yeah, and at first I was wondering, who would actually have 1,000 Kubernetes clusters? That's crazy. But it's actually starting to happen in the wild, and the reason is edge computing, edge analytics.
Now that, I know for me that's kind of a fairly new world. I understand the concept of it, like IoT. Yes, we want to put IoT devices at the edge to collect information. What are some real world company situations where they have IoT edge analytics?
Yeah, so it's becoming just increasingly popular. With sensors. One example I like to use is thinking of the distributed power grid. So think about all of the new devices that are showing up on the power grid. I've got solar panels on my roof. I buy a Tesla battery and I bury that out in the yard. I've got a car that I can charge it from my house, but if you saw the new F-150, the electric F-150 can actually charge your house. Right.
Which is nuts. I just got my Tesla, and I'm like, man, I want the F-150 now. Dang it.
Right. Bigger front. So So that's one of the areas we're seeing a lot of innovation is distributed analytics. The power grid needs to be able to react quickly, right? If a cloud comes out and my solar panels are now, unable to create power, I need to quickly switch to drawing from the grid. And the grid needs to be able to make decisions about where it's sending power. So that there's a lot of sensors running out on the power grid, and the ability to kind of redirect power so that you don't have to constantly have a lot of extra capacity on your power plants now is it's becoming huge, because it's no longer just a big power plant distributing power out to cities within 100 miles. It's a ton of small power producers in the middle. So being able to make quick decisions at the edge on where to redirect power is a big application.
So just to kind of dive deeper to make sure I have a clear picture of what this looks like. So we're talking about having IoT devices at the edge, and we're talking about having Kubernetes nodes or clusters, whatever you want to call them. What's the actual name for like a container in Kubernetes? What's it called? Is that a node?
It is a pod.
A pod,
An actual
that's
so
right.
container is a pod, and then one Kubernetes node can run multiple pods.
That's right. So the node's kind of like the host, and then the pod is like the container. Okay, gotcha. So on the edge, if you want to collect data analytics off the solar panels, you would have some sort of infrastructure there running a Kubernetes pod to collect that information at the edge.
Exactly.
What would that normally look like? Would it be like a mini little server, Intel NUC? Like what are we talking about?
Yeah, really. If you look kind of all over the place, you see these boxes at streetlights, right? Every time there's a street light, there's a little box off to the edge, and that actually hosts computers.
That's so crazy.
Little racked computers in there now, probably around the size of a NUC, but they're going to be a little hardened, right? They're going to have
little weatherproofing and stuff.
Right, weatherproofing, potentially fanless cases, multiple architectures, right? Some of these could be running x86, some could be running ARM. So lots of different options, but basically think small clusters out in many different locations within a city. Another use case is 5G, right? The 5G towers, super quick speed, right? To your phone, and now you want the ability to make super fast decisions to serve content to somebody, real-time decisions. Think, AR, right? Augmented reality. You don't have time to go up to a central server in order to give an AR overlay to somebody who's walking around downtown and trying to have AR directions to get to their favorite coffee shop or their favorite bar down there. So you need to make very quick decisions, have that edge computing that's able to serve low latency content out to a phone on a 5G network.
Which, a lot of people don't get that. Like, that's the true power of like what 5G is going to give us. And I was talking with Verizon about this, is that, it's giving us the ability to put things at the edge, because with applications like AR, which is going to become more popular, it's going to be the thing. Latency, even just a few milliseconds, can change the game.
Definitely.
It'll change your experience altogether. I'm curious, do you guys have customers that are actually using stuff like this?
We're starting to see people explore it, kind of exploratory phases, and kind of all of the ideas are there around it. And now you're seeing some of the early architectures being built and prototyped, and people marching towards production with some of these ideas.
Okay.
Yeah, so it's the early days for sure.
Oh yeah, for sure.
But we are helping a lot of customers kind of with their edge computing journey, and one of the reasons we like to help them do it on Kubernetes is because it's so flexible. They're used to using Kubernetes in their data center, so the ability for the developers to build software in a similar way that they do today that runs in a data center, we're able to use these tools and say, continue to build software that way. We're just going to push it to the edge, and we're going to use a tool such as Rancher and Fleet to get that out to the edge.
You can deploy and manage the entire cluster with Rancher. It has all the capabilities.
All the capabilities to exactly anything that you can do to a single Kubernetes cluster. you can do in Rancher and coordinate it to basically do a mass update to either a portion of your clusters or all of your clusters. So let's say you have an edge application running, and it's an augmented reality application for directions within a city center. You're trying to overlay directions to get your favorite coffee shop downtown. So if we're using that as an example, you could have an update to your application. Now, you may just want to test it out, though. So let's say your big development center is in Chicago. You want to test it out in Chicago, within your block. So within the block around your headquarters. So what you can do in Fleet is you can say, okay, well, you can organize your clusters so that they're tagged by city. So you've got your Chicago clusters, your New York clusters, your Los Angeles clusters, and they're all tagged by, what city they're in. You can tell Fleet, okay, I just want to move my Chicago cluster to the latest version of my code. And then you could walk around outside, test out the latest version of your code, just within that one specific area. And once you're happy with the way everything looks, you can now tell Fleet, okay, no more constraint on location. Go ahead and send the latest version of my code out to every single cluster. And Fleet will coordinate that and make sure that all of those clusters are up to date. If there's any cluster that, let's say Los Angeles is having a rolling blackout today, and that cluster was actually offline when you pushed your update, well, next time that cluster comes back online, it's going to check with Fleet to say, hey, am I at the appropriate version I'm supposed to be at? And if it's not, it will pull down the latest updates.
I know when I've messed with Kubernetes, you have to get in the command line, the kubectl tool, and all that. Do you still have to use that with Rancher, or will Rancher kind of replace all that?
So there is some of when you're down in the weeds like that, there is still a lot of writing YAML. We'll say Kubernetes. They love the YAML configuration files. So what Rancher has done is they've actually extended Kubernetes. So they do this. They do this in a way that's called a custom resource definition. So Kubernetes has basically it's basically a plugin model. If we think about all of the other tools we're used to using, we're used to calling this plugins. Kubernetes calls it custom resources. And what Rancher has done is they've basically said, well, we're going to make a custom resource that is an abstraction over a set of clusters. And we're going to call that Fleet. So basically the same way in Kubernetes that you would start to build a pod, and then you may turn that pod into a deployment so that you can run multiple copies of that pod. Now you may choose to take that deployment and apply it under a Fleet resource. So that's saying, well, I want to take this deployment that can run multiple copies of a pod, and now I want to tell Fleet to run that deployment, and it'll run across multiple clusters.
That's awesome. Now, Rancher, it sounds like it's obviously a product that can deploy and manage large Kubernetes deployments. Would you recommend like someone who's just trying to mess around with Kubernetes, or maybe just has a small thing in their house, to use Rancher to manage that? Would that be even useful?
Definitely. I think in Rancher is great because you can run it on a single cluster or up to thousands of clusters, but it provides very good insight into what's going on.
Okay, right? And that's the biggest thing I love, because like when I'm just messing around in my lab and I deploy Kubernetes, a lot of the times I'm like, okay, what's it doing? What are the analytics? Yeah. What's going on? I have to go out and find something to overlay it, and it sounds like Rancher can do all that.
Yeah, and it's just a simple command to install Rancher and get it up and running on a single home cluster.
Oh, that was my next question. Yeah, so what's the installation like? Is it pretty hard? And is there a learning curve? Like, do you have to invest some time to learn how to use Rancher?
No, it's really easy. It's basically just one command to install all of the Rancher resources onto your cluster. And then after you do that, you can just log into the UI. It's just it'll basically tell Kubernetes to start running Rancher on my cluster, and it'll then have a UI that you can go to and pretty much do anything else from the UI. It does offer all of the command line options as well if you like to go deeper. It offers an API so that you could program against it with a
Ooh.
standard API, right? Which is very neat because if you think about how we were talking about the different flavors of Kubernetes, there may be different APIs for managing AWS cluster, a Google cluster, an Azure cluster. Uh,
Yeah. Okay.
there may be no API on your local Minikube cluster, right?
Mm-hmm.
So Rancher will give you a standard API surface that you can now program calls against these clusters.
That's
Um,
killer because I know there are so many products out there to solve this problem, like kind of like an API aggregator because there's an
mhm.
API for everything. And it's like, well, I don't want to have to sit here and like do all these different API calls, and it may not even have the interface I want to interact with. So Rancher
Yeah,
kind of consolidates all that. It doesn't matter where you go.
exactly, exactly.
That's
So
killer. Now,
very easy to get up and running. And then once you have Rancher up and running, you don't have to install it. Say you have a second home cluster. Say you've got, maybe you've got your cluster, first cluster on your Intel NUC, and then across the house or in the backyard, you want to set up a Raspberry Pi cluster. You don't even have to install Rancher on that second cluster. You can just import it. So Rancher will give you an import command, and it'll just install a small agent on that second cluster. Very lightweight footprint, uh, something that could easily run out on a Raspberry Pi cluster, and it will report data back to the main Rancher cluster, and then you can manage it basically from that single location.
dang. Okay, that sounds pretty fun. I want to get my hands on that. So I'm curious. Do you use like Kubernetes in your own or Rancher in your own lab? Do you do anything geeky in your house?
A little bit, yeah.
What do
I
you kind of have
have
going on?
mainly around Christmas time. I will get my Raspberry Pi cluster out and hook it up to the Christmas tree,
Oh man.
uh, and that's where I like to basically will connect music, GPIO pins up to the Christmas lights,
Mm-hmm.
and then I'll be able to because you can't really interface with that little Raspberry Pi in the corner very easily, right? So I prefer to, then develop some custom software for that on my desktop and then ship that in a Docker container to run over on my Raspberry Pi cluster downstairs.
That is like one of the geekiest things I've ever heard, and it's
Yeah,
awesome.
yeah.
That's so cool. No, I've always had this confusion, and you can probably answer this so easily. Kubernetes, like KAS versus K3S, what is that? Is it just a smaller, lightweight version?
Yeah, that's exactly right. So K8S is kind of the name that Kubernetes got just as a shorthand way of writing it,
Right.
since it is a bit of a pain to write. So it's abbreviate K8S. So K3S started as kind of a joke, the naming at least.
Mm-hmm.
It's just less than K8S. It's five less than K. So what in reality what it is it's a stripped down version. It's got everything Kubernetes needs to run, but it does it with a much lighter weight footprint, and it's more geared towards running on your edge clusters.
Oh, okay. So you might see that people run the full Kubernetes suite. I don't know if you call it suite, like in their
Hmm.
enterprise and their data centers, but they want to run it on the edge, IoT devices.
Yeah,
They'll run
exactly.
K3S. Okay.
Right, because standard Kubernetes, has some dependencies you have to ship with it. It's got a highly redundant database called etcd, typically that is used to store all of the cluster state, and that's great for the enterprise, right? It's highly resilient, highly redundant. Um, it's gonna survive multiple nodes going down, right? But when you've just got a box a box sitting next to a traffic light or a box at the base of a 5G cluster, you already have redundancy in your network. It's already okay if maybe that site goes offline because the site next door can pick it up. So you don't need to run, a full rack. You don't need to run a full data center on your edge clusters. What you want is a cost-friendly way, low resource footprint, a way to run in maybe a low power mode, and K3S is going to be friendly for all of those scenarios.
That sounds awesome. Now, I'm curious, and this question popped in my mind as you were talking. I know Kubernetes, I don't know much about how Kubernetes handles storage, but does Rancher kind of abstract that as well and kind of handle that part for you as well?
Oh, so what Rancher does is it actually, it stores its own data inside of Kubernetes. So the idea with that is Kubernetes already has a highly redundant data store, right? And Kubernetes stores all of its state information. So what Rancher actually does is it extends the Kubernetes API, again, in the way we were talking about, same way that Fleet does. Rancher extends the Kubernetes API and stores all of the Rancher data in Kubernetes. So you can install Rancher and you don't even have to run your own database for it. It's just going to store its data next to all of the Kubernetes data, which is really nice, because I don't know how many times you've gone to install a piece of software, even something as simple as WordPress, and you're like, man, first thing I have to set up is a database, right?
I know.
And redundancy for my database, and figure out my connection string and store my password somewhere secure, right? So Rancher is actually very nice in that it hooks right into what Kubernetes already brings. So no matter where you're running that, if you're running in the cloud, with a super redundant cloud provider managing your Kubernetes API persistence, Rancher is going to hook into that same method.
Okay, that's awesome. Now, you probably already answered this, and I wasn't listening properly. As far as like setting up Rancher, do you already have to have Kubernetes prereqs installed and everything, then you install Rancher on top of that, or can Rancher handle the Kubernetes install for you and just do everything?
So Rancher
and of course, I'm talking about more of like on-prem, like cloud already have that service built in.
Exactly, definitely. Rancher in the sense when we talk about the Rancher management plane is going to install onto an existing Kubernetes cluster. Now, the great thing, if you don't have an existing Kubernetes cluster, if you're running on-prem, Rancher actually provides, it's called RKE, Rancher Kubernetes Engine. They provide their own distribution of Kubernetes, which you can use to set that up. So
okay, awesome. So if I were like, I've got a fresh virtual machine or whatever, and I just want to test this out, I can use RKE, I can use Rancher just to deploy the whole thing.
Yes, you can use RKE to bootstrap it, and then you'll have that whole Rancher management UI on there once it's ready. You can install the Rancher management UI on it. So they do have kind of a full lifecycle on-premise solution called RKE. And the great thing about RKE is upgrades are part of the RKE suite as well. So Kubernetes upgrades have always been painful. RKE makes them a little less painful because it's going to basically provide certified versions of Kubernetes. So when it's time to go to the next minor version, time to go from 1.19 to 1.20. RKE has already vetted out all of those Kubernetes components, figured out which ones work best together, and they provide the upgrade path for you.
Now, is that what you normally see when you work with customers? Like you're going to use RKE, or is it normally they already have Kubernetes installed, you just kind of put Rancher on top?
Yeah, it's kind of a mix. A lot of times they will already have, if it's the cloud, definitely they'll have the cloud providers version, so that EKS on Amazon, the Elastic Kubernetes service, AKS on Azure Kubernetes service, and then GKE on Google, which is
all these acronyms.
Google Kubernetes Engine. So those are going to be your typical cloud clusters, right? And they already have their own upgrade mechanism that you'll continue to use your cloud lifecycle tools, cloud providers' lifecycle tools. Rancher will just provide you insight into those clusters. But then for your on-prem clusters, RKE is a hugely popular option. So you can install, Rancher end-to-end using RKE to manage your cluster lifecycle. And Rancher, the Rancher UI is actually smart enough to see the differences between these clusters. So when it
Oh.
sees a cloud provider cluster, it won't try to upgrade it. But when it sees an RKE cluster, it'll say, hey, I've got an upgrade for this. It's time to upgrade. Here's the button, right? And it'll do all of those automated tasks, painful tasks associated with an upgrade. It'll do them all for you.
Now, again, you probably already answered this, but as far as like where Rancher is hosted, so you install on top of Kubernetes, maybe on the same box, I'm assuming. Would you often have that on its own host just for scalability? I don't know. Do you need multiple hosts for redundancy? How does that look?
So you have options. I think in a highly scalable scenario, you would want to segment off Rancher. That is the recommended approach, is to go ahead and have a cluster that just Rancher runs on, right? And that's kind of your central point. You go there first, and then you stand up all of your other clusters to run your applications on. But if you're looking to do just a small deployment and get started with it today, it's totally okay to put everything on the same cluster. So install Rancher on your test cluster, install your apps on your test cluster. So it is a flexible deployment model.
Okay, awesome. And then as far as like when you interface with Amazon's EKS or whatever it is, how does Rancher connect to it? What's the mechanism?
So Rancher will do centralized authentication and authorization. So what's great is that I can log into Rancher as a Rancher-wide admin. I can choose which developers in my organizations, which other DevOps members or which ops members can have access to different clusters. So let's say we have an EKS cluster at Amazon. We've got two of them, our dev and our prod clusters. So I can give all of my developers access through Rancher to my dev cluster, and then I can give DevOps and Ops access to dev and prod. And what Rancher does is it actually sits there as a transparent proxy. So everyone connects to Rancher, and then Rancher has all those authentication rules built into it, and it knows who you are when you connect to it. So it's basically a transparent authorization proxy to all of these other clusters. So I didn't have to go into AWS and create, shadow user accounts for everyone. I just had to make sure they were able to access Rancher, and with just Rancher, they're now able to have their commands authenticated and then proxied to the appropriate clusters.
That's awesome. And I assume Rancher integrates with like AD or something as far as like authentication.
Oh yeah. Yeah, they've got lots of options, AD, all the big ones, as far as like social login, so Google, Microsoft, Office 365, SAML connector, if you want to do completely custom. So they've got a lot of those options. And it's not too bad to configure.
No,
we always love guessing at the AD and SAML options when we're integrating apps, but
oh yeah, it's always a pain point, just all the different options and stuff. My goodness. So I know Rancher's not the only app out there that does this kind of stuff. Why did you guys choose Rancher? Why does Boxboat partner with Rancher? And I guess the company's SUSE. Is that how you say it?
Mm-hmm.
Okay. Yeah. So why did you guys choose them? What's the big killer thing that makes you want to deploy them to everyone?
So what's kind of funny is we started deploying Rancher at places we were going before we were even partners with them. The thing we liked about all of the developers or all of the DevOps engineers at Boxboat, we really liked Rancher because it was open source. It was completely free to try, and it provides such a good management interface into multiple clusters, solved so many pain points for our customers. We had started using it, back when they were a smaller company, back when Rancher was a smaller company, trying to gain a foothold on the market, trying to gain traction. Mm-hmm. And we just started putting it places. And then, somebody got the bright idea of like, hey, maybe we should call these guys, since we like them so much and people are starting to ask for support. Maybe we should call these guys and partner with them. So that's exactly what we did. And Rancher has since grown over the years to offer, these great Kubernetes integration features, and they were acquired by SUSE last year. So they are new to the SUSE family. SUSE, of course, is like some people describe them as like a European version of Red Hat.
Oh.
They're an open source Linux company already.
Mm-hmm.
So great fit for an open source Kubernetes product. And, so now Rancher is under the SUSE family and just continues to receive features and attention from them.
Yeah, it's always good to see these, I guess you wouldn't call them small, but like kind of small companies get snatched up by these larger companies because it does offer like some more structure. They get more updates and features, more, I guess more devs behind it to empower them. So that's always cool.
Yeah, and it's definitely a good affirmation that like, hey, this product has, proven its worth and, is going to be around long term and going to be something you can rely on.
Now, is Rancher primarily just focused on Kubernetes, or do they do anything else as far as integrations and management?
Their primary focus is Kubernetes. So I think that, Edge has been the focus lately. So Fleet has been a huge focus, and there's a lot of, there's a lot of cycles going into, expanding just upon the one, expanding out from a handful of clusters to thousands of clusters. So it'll be fun to see how the edge play kind of goes. We hear all this talk about it, and definitely a lot of people starting to work on it. And it'll be fun to watch.
And I know we kind of touched on this already, but it's so funny to see how the market does change a bit because, I mean, gosh, I think it used to be that we want to do edge computing, and then we switched back to everything being centralized. Now we're looking at doing edge again. Do you see like more increasingly as time goes on, it's going to be more focused on the edge just because it gives us that better performance?
So I think that data has always been the problem, right? Our database has always typically been the problem with moving away, even when people talk about going multi-regional, right? The database is always the issue, and latency is always the issue. And I think the appeal of edge is takes a bit of a transformation to say, okay, we're no longer going to depend on just our database running in our main location, right? We need to rethink how we build our apps. And a lot of these new like cloud native databases that are kind of able to reconcile data globally, right? Maybe it's through eventual consistency or some other method, or pushing centralized data out to the edge, and then just making decisions on that data out at the edge level, and kind of synchronizing data. I think that with a wholesome approach to no longer focus on that central database anymore, your massive Oracle database or whatever you've got running on your mainframe, right? People are finally starting to break the trend on that, and use some of these newer data products. I think that's just going to accelerate, the ability for edge computing in general. Because once you can run across regions, there's no reason you can't run at the edge, right? Once you don't have that dependency, if you can do an East Coast, West Coast and figure that out, you should be able to figure out, many different clusters on top of that. So I think that's probably what's taken so long, ecosystem-wise. But maybe this time it'll work since now we've got all the right building blocks to kind of spread data around.
Right. It seems like everything's kind of coming into place now. Now I'm curious. I know. I think every cloud provider is kind of doing their own version of it, but I know AWS has what's called their wavelength zones. Have you heard about those?
I haven't.
Oh, okay.
I haven't read into that one yet.
It's sort of like their 5G play where they're putting their like small versions of their infrastructure in like.
Oh yeah.
And like the
Okay,
Verizon
no,
data
I have.
center.
They're like the regional availability zones, right?
Yeah, exactly.
Okay,
exactly.
Did they rename those wavelength zones?
Yeah. They're like Verizon was partnering with me on that. They're kind of just throwing their infrastructure in Verizon's data center and AT&T's or whatever.
Yeah.
So it's like that quick, low latency 5G connection. And I'm
Right.
curious if
Okay.
And I guess with Rancher, it wouldn't matter where you put your cluster, because if it's in an availability zone that's close to somewhere else, then you can just throw it there.
Yeah, so Rancher would be your kind of centralized management. You still would have that in your primary data center. But then it would be, you would be able to connect all of these regional or wavelength zones back to Rancher. That's basically the way Fleet is built to work anyways, is through that eventual consistency, right? You tell Fleet, hey, here's what I want my clusters to look like. And then your clusters talk back and they kind of figure it out. So, we're in a world now where everything's not online all the time, right? There could be, network outages, power outages. You could just have something offline for maintenance. So Rancher has really taken that decentralized approach, to where, I guess it's technically not decentralized, but they've taken an asynchronous approach to where things can come online at any time and just figure out what they're supposed to do. So it's really a kind of, here's my desired state of all of my clusters, and then they'll come online and figure it out.
Now I'm curious, and this is probably the last question because we're running out of time here. As far as because I know that the big thing is automation with Kubernetes and Rancher being able to say, okay, this host went down, or this pod is not, let's shut that down and direct people over there. What can Rancher react to? Can it react to internet outages? Okay, this region we lost connectivity. Let's spin up some pods over here to give that more power so people can connect that way. Is that what it kind of does, or do you rely on other tools for that?
You would rely on other tools for that, but the nice thing about Rancher would be that standard API. So could
those
gather
other tools could just tell a Rancher to do that. Yeah.
Yeah, and you can gather those metrics. So Rancher does know when clusters go offline or nodes in a cluster go offline, and I could take many different cloud providers, hook them all to Rancher, and then with standard API calls get a list of every degraded cluster. And then I could, maybe write some integration on top of that, to go spin up or spin down nodes in certain areas. So it does have nice single pane of glass for the UI and the API surface. That's going to allow you to do that.
That's awesome. Well, Caleb, I think we covered it all, man.
Okay. Awesome.
Any passing words of wisdom or anything about Rancher that you want to include that we didn't talk about?
No, I think we did a pretty good job hitting it all.
Yeah, you did great.
Cool.
I came into this knowing pretty much nothing about Rancher, so you gave me a great starting point to go with this, and it's going to be great for the video.